Now here's the thing with solving graphically. Solving graphically leaves a little bit of room for error here because, you know, even if you have a ruler and you draw a line, it's possible that you're going to be off some. And like, you know, while you can assume that if I give it to you in a test or quiz, it's going to cross, but that's not true of all systems of equations. You can have fractions and decimals as an answer. And so then when you get into fractions and decimals as an answer, then you get into a problem with just sketching a graph, because when you sketch a graph, you're going to have to estimate what that answer is if you are having something in between integers, right? Rational numbers here. So there are ways to solve it algebraically that you always get the same answer, assuming you do it correctly algebraically, but it is, whether it is a decimal or a fraction, you're going to get the exact answer. You don't have to make sure that you haven't drawn it incorrectly. The first way to do it is substitution. And you know, substitution is exactly what it sounds like. When you substitute in a game, someone replaces another player. When you substitute algebraically, you just replace something with whatever it equals, all right? Something set up like this is really simple to do substitution. With substitution, you have to make sure you have a variable all by itself. Well, you'll notice in the second equation, you have a variable all by itself. Once you have a variable all by itself, you're going to take what that variable equals, which is the x minus 8, and you are going to substitute it into the other equation. So I am going to rewrite my first equation, which is 3x plus y equals negative 20. But instead of writing y, I'm going to write what y equals from the second equation. So y equals x minus 8. What this does is this allows me to have now one variable. Once I have one variable in an equation, I can just solve the equation. So if I were to solve this, combine your like terms, 3x and 1x. Add my 8 over. So I have 4x equals negative 12. And then I need to divide by 4. So x equals negative 3. Now, when you're solving algebraically, you will always solve for one variable first, but my answers are a point on the coordinate plane. In order to have a point on the coordinate plane, I need an x, but I also need a y. Just like when you graphed, I needed an xy as my answer. When you solve algebraically, you need an xy as your answer. You're not done yet. But once you have this guy, you can plug it in. Y equals x minus 8. Well, I know what x is, so I can just plug x in. Y equals negative 3 minus 8, so y equals negative 11. So now I know the point that I'm looking for is negative 3, negative 11, right? And this is my answer right here. And you can check it. If you check it, you plug in a negative 3 and a negative 11 here. Negative 9 plus negative 11 is negative 20, correct. Plug in a negative 3 and a negative 11 here. Negative 11 equals negative 3 minus 8, correct. All right, so once you solve this, plugging it in will show that you have the right answer. It should make a true statement for both of those equations. Your x and y will make a true statement. So negative 3, negative 11 is my answer here. So I already have a y by itself. You're just going to take it and plug it in for the y. Now you'll notice in this example, I do not have a variable by itself, all right? I have a 2 in front of my x here. I have a negative y here. I have 4x and a 3y. I don't have any variables by itself. Now, it doesn't mean that it's not necessarily easier to solve by substitution, but it does mean that I need to take one of those equations and get a variable by itself. So I'm going to choose the equation that is the easiest to deal with, all right? And in this case, I almost have a y by itself. Everybody see that? Granted, it's not by itself on one side of the equation, but it almost is. So I can say, well, I can easily get the y by itself by moving the 2x over. And then dividing by the negative 1. So I have y equals positive 2x minus 8. Now I have one of them by themselves, okay? So now I can take this And I can plug it in for y. That's what I got by itself, was the y. So you go to the other equation and you plug that guy in. 4x plus 3. You'll notice that I am putting parentheses around this when I plug it in. Why is that important? Well, that 3 has to distribute to that entire group. But I already now have something I can solve. I'm going to distribute that 3. 3 and 2x is 6x. 3 and negative 8 is negative 24. Now I have something I can easily solve. Combine my like terms. But they did give me a fraction, by the way. 10x equals 26. X equals 26 over 10. Reduce it. 13 over 5. All right. Now, 13 over 5 is hideous, but we can still solve for it, right? I have my x value, 13 over 5. I need to find my y value, so I'm just going to plug it in. 2 over 1, 13 over 5. So I have 26 over 5. My common denominator is 5. Right. I'm going to get negative 14 over 5, which is my y. That would have been really difficult to solve graphically, okay? Do you see how 13 over 5 and negative 14 over 5 would have been a pain to try to figure out on a graph that you had those numbers, right? But algebraically, even if it's a fraction decimal, you can solve for it, all right? So if it is like the second one and you almost have something by itself, you're going to solve for the easiest one, get it by itself, and then plug it in to your secondary equation and then solve. But remember, you're going to solve for one variable and you're not done. You've got to go back and solve for your second variable. And you don't necessarily always solve for x first, okay? It's whatever variable's easiest. So let's look at these. For these, I have either an x or a y by itself, close to it, that I can get. And here, I'm going to try to figure out which is the easiest to get by itself without creating fractions. So you'll notice on this one was way more difficult to do substitution. I mean, there was really only one variable that was nicely solvable, and it wasn't glaringly obvious, right? Because you had a 2x here, so it's not like I even took the smallest of the coefficients necessarily. So there are going to be times when maybe substitution isn't the easiest way to do it, right? Graphing has its limitations, but it's fairly simple. It's just limited if you have something other than integers as your answer. Substitution, when your variables are very quickly isolated, substitution's not that hard, right? You just plug it in and solve for a variable. But there are going to be times when substitution's a little more tedious, and possible room for error. And especially if the only way to substitute would have been to get fractions here, then all of a sudden substitution is not the easiest method. So then we have a method called elimination. Solving by elimination. This is the top of page 114, okay? So with elimination, basically what you're trying to do is you're trying to get one of your variables with the coefficients that are just opposites. +2, -2, +1, -1, +3, -3, right? And then when you get one of the variables that the coefficients are opposites, you just add straight down, and that variable will eliminate, and you can solve for the one that's left over. This is sometimes called solving by addition. All right, but what you're really trying to do is eliminate a variable. So for something like this, substitution may be rather simple because you have a variable easy to get isolated. But another way to do this is to solve by elimination. So with elimination, you pick one of your variables and you say, well, can I get my variables to be opposite of each other? My x's have a 1 and a 2. They would not be the easiest thing. My y's have a 1 and a 1. So if you have a 1 and a 1, you can technically just subtract here, but the rule is to get it to be the opposite. So if I want it to be the opposite, then I can say, well, I am going to multiply everything in this by -1. That makes my x a -x. That makes my y a -y. That makes my -1 a +1. For this particular case, I'm going to leave the second equation alone. 2x plus y equals 2. Now what you'll notice is I now have a -1y and a +1y. This is my goal for elimination. -1, +1. Okay? And so now that I have it like this, I am simply going to add those down. So I'm going to say -1x and a +2x. That gives me just x. -1y, +1y, those cancel out. That gives me 0. Bring down this equal sign. And then I have a 1 plus a 2 equals 3. And you can see I have solved for my x. Now, as all of these are, I only have one of my two variables. I can go back to either of my original equations and I can plug it in. So if I have x plus y equals -1, and I know what x is, 3 plus y equals -1. Solve for that by subtracting my 3. Y equals -4. And now I have my entire solution, 3, -4. That is elimination, okay? You are eliminating one of your variables. Now, when you already have coefficients that are almost the same, they just need to be negated. Just negate one of your equations all the way across and add it down, okay? Now, there are going to be times, though, when you don't have them directly opposite of each other. Look at example 4. All right, you'll notice here, none of my coefficients are the same number. Here I have a 7 and a 5 for my x's, and I have a 6 and a 2 for my y's. But one of these is easier to get to an opposite than the other. If I were to do 7 and 5, I would have to get a multiple that's true for both of those, right? Which would be like, what, 35? We don't want to get that to 35. But between 6 and 2, I can actually just change the 2, right? I can multiply him by what? 3. And specifically, I want him to be a -6, so I need to multiply by -3. So I'm going to take this entire equation and I'm going to multiply by -3. I'm going to leave my top equation alone. 7x plus 6y equals negative 4. I'm going to multiply everything in here. 3 times 5x, that's negative 15x. 3 times positive 2y, that's negative 6y, which is my goal. 3 times positive 1 is negative 4. All right? And then I am going to add down, right? Now, your goal of adding down is that one of these eliminates. If you add down and nothing eliminates, you did something wrong in the first step, okay? All right, so my goal here is to add down and eliminate. 7 and negative 15 give me what? Negative 8. Here, this should cancel. So now I have an equal sign. Negative 4 and negative 3 give me negative 7. All I have to do is to divide. My x is going to equal positive 7 over 8. Again, I only have one of my answers. I need 2 of them. So I need to plug it back in. You can plug it back into either one. It doesn't matter which one. I would probably go with the bottom one because it's smaller numbers. So 5 times 7 over 8 plus 2 times y equals 1. We have 35 over 8 plus 2y equals 1. Remember, to get this as a common denominator, it's just going to be 8 over 8. 8 over 8, subtract this over. 2y equals 8 over 8 minus 35 over 8. All right, subtract, we get negative 27 over 8. What's my last step? Divide by 2. What's the same thing? I can multiply by what? Dividing by 2 is the same thing as multiplying by as 1/2, right? Multiply by the reciprocal. I'm only saying that because we have a fraction on the other side, right? So to divide by 2 is to multiply by 1/2. So if you multiply by 1/2, you get negative 27 over 16. If you divide by 2, sometimes people get confused. A fraction divided by a fraction. So negative 27 over 16 is my y value.